Thanks everyone for being here. So I'm gonna preface this by saying I'm definitely not an expert in this subject matter. So it's really cool hearing, what other people have, seen WebGL being used for, talking about kind of different 3D rendering software, which I've dabbled in a little bit and also am hugely intimidated by. But it's always been something that I've thought is like super interesting. I love seeing WebGL projects on the web, so I wanted to learn a bit more about them and share some of that knowledge with all of you. So without further ado, can everyone see my screen? I got a thumbs up. Yeah,
Yep.
good. Okay, cool. Just a basic overview, WebGL, Web Graphics Library, it's basically a JavaScript API that you use to render high performance 3D graphics or 2D. It doesn't have to be 3D. And it's able to do this because it can tap into your computer or your device's GPU or graphics processing unit, which is essentially just lets you render kind of visuals much better. I don't know the details, but something about the circuits are optimized for graphics specifically. So what is it? It's a low-level API. It's based on OpenGL ES, which is a shading language. We'll talk a little bit about that. And you interact with it using the HTML5 canvas element. So probably some of especially the front-end developers will have worked with canvas elements before. And so that part might be a bit familiar. WebGL, kind of an initial foundation and concept, was built in 2006 by a guy, Vladimir Vukosevic. And then browsers kind of started to adopt it over the next few years. And it's currently kind of developed and maintained by the nonprofit Kronos Group. So I've got what, how, when, who kind of answered here. And then I think the why should be pretty self-explanatory, especially if you're looking at any of those links we were playing with earlier. It's just really cool. It's a really powerful way to add life to the web and browsers. Okay, so moving on. Just a brief visual on browser support. Browser support's pretty good for WebGL these days, at least if you're on the latest version. Basically all the major browsers, including mobile browsers, are supporting WebGL to some extent. Being able to run an application that's using WebGL also requires certain like device and hardware specifications, which I don't actually have the specifics on. So you need a GPU, and I don't know exactly what that requires, but any iPhone should be able to run it. I think most Androids, most kind of modern smartphones as well as modern browsers. So quick kind of pros and cons of WebGL. WebGL is open source, so you can always look into all the source code and kind of dig into the nitty gritty of how it works. It's super easy to, it's very easy in that it doesn't really require any sort of environment setup. You can start working with WebGL in just any old JavaScript environment. There are some complexities, which I'm going to get into. It works in most modern browsers, as we saw, and you get to use JavaScript, which is one of the most popular coding languages right now. So a lot of people kind of have access to this, this really powerful API. It integrates with the DOM. You don't have to worry about like memory management. Disadvantages: not all browsers, especially older browsers, are not going to support it. Complexity: this is kind of the big one. It has quite a steep learning curve. And I think that's, for me at least, was kind of the biggest disadvantage. And I'll share my experience with that in a moment. So the basics of a WebGL application, it consists of both normal JavaScript as well as shader code, or GLSL, which stands for Graphics Library Shading Language, I believe. And that code is what's executed by your device's like GPU. So in a WebGL application, you've got kind of two bits of GLSL code. You've got your vertex shaders and your fragment shaders. So vertex is, the name kind of hints at what it does. It basically is tracking all the points in your objects and kind of your 3D primitives, and basically is controls like updating coordinates as movement occurs. So it's basically keeping track of all those points in space that form your objects. And then a fragment shader is essentially responsible for the coloring. And it's not just straight up, red, yellow, green. It needs to calculate based on the material and the lighting and kind of the color of the material. And based on those different things, it'll apply kind of the exact pixel value. Okay, and so together, vertex shader and fragment shader forms a shader program, and they're the basis of kind of all these WebGL applications. Okay, I'm gonna pause real quick. If anyone has any questions, just take a moment. Okay, no questions, that's good, because you're not allowed to ask questions for the next couple minutes. So this week, really, I attempted to dive in to really understand how the WebGL API works. And I learned about vertex and fragment shaders, and those kind of made sense to me. And then I started putting them together with JavaScript, following various tutorials. So initializing shaders, learning about buffers and attributes, uniforms, textures, variants. You have to render a scene. Then you're updating the scene to make sure it's animating properly. You do matrix math, coloring different fragments, more matrix math. You add movement, there's more matrix math. You start to see code like this, and very, very quickly, it got super overwhelming. These are things that I experienced: confusion, frustration, and despair. So I'm going to pause, and I'm actually show you kind of the code that I have for my simple WebGL application. So it's just I went for the absolute, minimal setup. And in my JavaScript, you can see we're setting up a canvas, which is how you interact with the WebGL API. And then these two blocks of code right here are the vertex shader and the fragment shader. And you can actually see these are written as just strings in JavaScript, but the code itself is actually GLSL, which I think, and I'm not super familiar with C, but my understanding is that it resembles C, C++ quite a bit. These are the shaders that we talked about. And then here is some of the JavaScript that I had to write in order to put together a very simple program. This is like the most basic tutorial I could find. We've got some buffers. Here's a matrix containing positions and coordinates. Here's a matrix containing colors. We're drawing a scene, more JavaScript, and it basically hit like 200 lines of JavaScript. And I'm going to show you what that got me. I was very excited, and then slightly disappointed when this appeared on my screen. So this is the result of all that code. It's completely static. There's no interaction. It's just a square with some colors. So that's essentially what led me to confusion, frustration, and despair. However, for one thing, you can learn all of this. It's definitely possible. I think the barrier for me and for a lot of web developers is that a lot of the things you would need to learn in order to make these WebGL applications are really not useful things in other areas of software development and engineering. So it really kind of lends itself to like graphics specialists or 3D specialists. Fortunately, there are a bunch of awesome JavaScript libraries and other tools that allow anyone to work with WebGL. So I've listed out a few of them here. Let's see, Pixie, Phaser, P5, and 3JS are kind of ones that I have heard of or worked with before. And specifically 3JS I'm going to talk about a little bit. I think it's probably the most popular one for kind of a 3D rendering library. I know someone was talking about that just a few minutes ago in the chat. So I'm going to show you quickly what I was able to do using 3JS in much less time and a lot fewer lines of code. Bear with me while I bring up the actual code. All right, so in the native WebGL program, we had about 200 lines of code. And this one is a very similar setup, just super simple bare bones web page with some JavaScript. And we've got basically like 40 lines of code. I'm also importing a 3D model, which is this .glb file. And I'll show you the result of that. So that gets us this. So this is a 3D model of the International Space Station. Let me just reload it quick. And within those 40 lines of code, I have a super, super high-res free 3D model of the International Space Station. I can control it. I can move around using different tracking controls with my mouse. You can see there's some cool lighting. I think if I zoom out a bit and well, you can kind of see the reflection. There we go. Yeah, there's kind of like a reflection of the light. So that's a fragment shader, calculating those pixels. And then just for fun, I also added in just a very primitive shape, just a sphere, just left as a wireframe. The intention could be, oh, this could be the moon or the earth or something, if I were making a fleshed out program. So that was way, way, way easier for me to do than actually work with the native WebGL. And quite honestly, I think that's the route I'm going to take going forward. And that's certainly what I would suggest to pretty much any kind of JavaScript engineers, unless you're really, really motivated to get into graphics, in which case, power to you. Definitely dig into the WebGL API. Yeah, so, okay, I think that was pretty much my experience. So just to kind of sum it up, WebGL is a really powerful tool for making 3D renderings on the web. You can make them really interactive, and we saw some of those links in the chat earlier. I really think it's the API is kind of too complex to really be worth learning for the majority of JavaScript engineers. But if you're really into graphics and 3D and you work with 3D models, I think it would probably be very rewarding to learn. I myself am going to stick with 3JS and other libraries to do the heavy lifting though. So that's it. That was my talk. I have some links here for a few different kind of tutorials, and also the kind of example repos that I demonstrated.